Hey kids, Charlie Busso here, and we're going to be doing page 7 in the bonding notes. All right, covalent bonding, two or more non-metals. They do not make ions. No ions ever. With ionic bonding, there is a loss or transfer of electrons. In covalent bonding, there is a share of electrons. This is super duper important right here. The main difference between ionic bonding and covalent bonding, first of all, in covalent bonding, there's two or more nonmetals. In ionic bonding, there's a metal and a nonmetal, and they transfer electrons. Ionic bonding transfers electrons. Metal lose electrons, nonmetals gain electrons. There's a transfer of electrons, whereas in covalent bonding, there's a sharing of electrons. In covalent bonding, there are no metals ever. So whenever you're looking at a compound, if the first element in the formula or the name is a metal, then it's ionic. And if the first name is a nonmetal, there's only 22 of them, and 7 or 8 of them are noble gases. If the first name's a nonmetal, then it's going to make covalent bonding. Okay? Covalent bonds form by sharing electrons. Molecules form with covalent bonding. Covalent bonds. A molecule is two or more nonmetals that are sharing electrons that form a new particle of two or more atoms bonded together that's got new properties. Now, we're going to draw some Lewis dot diagrams. Hydrogen has one electron. That's the entire electron orbital. So hydrogen is going to look like that. When H2 forms, you've got to have two hydrogens. They're going to share one pair of electrons. They're going to share one pair of electrons. Now for F2, F has 7 valence electrons. How do I know that? Put your finger in box number 9 on the periodic table. Fluorine has a 2-7 electron configuration. There's the 7. Now if we have F2, that means we have to have 2 fluorines bonded together. Right next to this F, I'm going to put another one. Watch this. 1, 2, 3, 4, 5, 6, and I'm going to put 1 in there. And watch what I do right here. Look, we're going to share one pair of electrons right inside there, right in the middle. Between the F's, they share one pair of electrons. In covalent bonds, all atoms get full outer orbitals. And I'm going to write octet rule, right? They always get full outer orbitals. Usually it's an octet. Look right here. 7 plus 1 and 7 plus 1. Each of these atoms ends up with 8, whereas hydrogens both end up with 2 and 2, but they're both full. This is too small. So the rule really is they always end up with full outer orbitals, but the state likes to call it the octet rule because usually that means 8. The bonds for H2 and F2 are called single nonpolar covalent bonds because they only share one pair of electrons and the two atoms have no difference in their what's called electronegativity value. There's no difference in the electronegativity value. So F2 and H2 have single nonpolar covalent bonds. HCl, I'm going to use 2 different colors. H gets 1 single dot. Chlorine, which has got to be snug right up, has 7 dots. You see in the middle, there's 1 hydrogen black dot and 1 chlorine red dot. That is called a single And now if we look at the the electronegativity values, this is a 2.2 and this is a 3.2. So this is a single polar covalent bond, because there's a difference in electronegativity. Now for water, water has oxygen, and oxygen has 6 electrons that are going to open up that way. Let me make this a little easier for you to see. The hydrogens are going to come in on 2 different directions, because we always say that water is bent. It is always bent. You can never make it a straight line. Now, hydrogen has a 2.2 and oxygen has a 3.4. So here we have 2 single polar covalent bonds. Inside one molecule, there's 2 bonds. There's the bond on the bottom between hydrogen and oxygen, and the bond on the side between a different hydrogen and oxygen. So here we have 2 separate bonds in the same molecule. They're both identical bonds. They're both single polar covalent bonds.